Welcome back to my channel Balvigyan Bharti, and this is your mentor Abhilash Sarkar. So what we did the up to the earlier videos, we have learned about vector coplanarity. Before that, vector collinearity we have learned, vector coplanarity we have learned. We have learned how to get a planes equation, how to get the normal vector equation from that planes equation, and we did some problem on the related subjects, that is how to two vectors or more than two vectors be collinear, how how two vectors are coplanar, that we have learned. And in the progress of that, we today will learn some more facts on vectors. And before that, I want to recall or recapitulate all the things we have learned in the last video, so that will help to analyze or describe my today's subject. So the thing we have learned about the plane equation of a plane equation, that is given by ax plus by plus cz is equal to d in the general form, and the normal vector on this, because if I talk about the Cartesian plane, this is z, this is x, this is y, and a plane given on the Cartesian plane, this is the normal drawn on that, and any position vector, let's say p, is x, y, z on the plane, and plane equation given, the normal vector is given by a, I, b, j, and c, k. This is the normal vector on this, and any point on p, if it is given by xi plus yj plus zk on the plane, then and another point, let's say q, it is a known point that is given by x0, y0, and z0. Then if I draw the pq vector, is another point q, which is this is p is a point which is a variable point. Qp may be anywhere, and q is the fixed point on the plane, and that is given by the coordinate x1 z. Then pq, if I join the vector pq, is given by x minus x0 I plus y minus y0 k, y0 j, and z minus z0 k. So this is the vector given by the 2 points on the plane given as this one. Now that pq, the normal vector to the pq, the dot product of normal vector to the pq vector will be, now this normal vector is perpendicular to the plane, that means it is perpendicular to the any vector given. So if it is a vector given, so pq dot n dot pq will be 0. Okay, because that is the pq, cos theta cos 90 is equal to 0, so that is equal to 0. From there we can come to the equation form, that is ax minus x0 plus b, means we are doing the dot product of this by putting the, let's say I'm taking it again, ai plus bj plus ck dot x minus x0 I plus y minus y0 k, j plus z minus z0 k. Now if I do the dot product of that, the result will become that is equal to 0. If I do, so it can convert it into this form, plus c into z minus z0 is equal to 0. Now if I further calculate, this can be turned into ax plus by plus cz, and this is equal to, on the right hand side it will go ax0 plus by0 plus cz0. Now any this x0 y0 z0 are on the plane itself, so this will be a constant d. So this the equation of a plane becomes this one. This is the equation of a plane that I have derived like this, and x y z will be any variable point on the plane, and d will be the value of this part when a particular point is taken. So this is for the understanding. Now we'll move, and then after we have derived the planes equations also, the normals equation that we have shown. You can go through that. So now the things we will calculate is the distance of a plane from a point. So when we do the distance of a point, distance of a plane from a point, we'll draw a vertical, and which will be the shortest distance. So this has to be the shortest distance of a point P, let's say. Okay, P, say I'm taking x0, y0 and z0, a static point on the plane. So there could be several distance on the plane from that point. So the shortest one will be the vertical one, and that is the distance. So that is same as if I draw a plane through the point P, will be the parallel distance between those planes. One plane is passing through the point from which the distance has to be calculated, the shortest distance. So now if two planes are parallel, so that is the same as the parallel distance from in between two parallel planes. So this would be in a manner being asked that you have to find the distance between the point to the plane and or the distance between the two parallel planes. So how will you do that? Now for that we'll do some assumptions and we'll put some conditions on that. So we have assumed a Cartesian plane, that is z, x and y. Okay, so now this is the plane we have assumed. This is P1, say. This is a point P. We have assumed x0, y0 and z0. From there we have dropped a vertical on this point. Let's say T is x1, y1 and z1. Another point P, another point Q, we have assuming that is a variable point, could be any point x, y, z, and we are drawing a normal onto that because we need that. So we are drawing a normal onto that, let's say N, and this is Q, and we are joining the point that P and Q. This is making an angle theta, so this also to be theta because both are vertical parallel lines. So this is intersecting line, and we are joining the thing onto the normal vector. So this will complete one triangle, and so of this we can join. Okay, so now if it is the d, distance between the point to the plane, the vertical distance we have to consider. So our aim has to find the d distance. Now if you will see this P, these are making right angle triangle. So any projection of this on the normal vector will be the same as the distance d. So the projection of PQ, let's say I'm projecting PQ on this. So this component, the adjacent side, the component will be PQ cos theta. That is nothing but this distance and equal to this distance. So d is nothing but PQ cos theta. Now come to that. So the plane equation P1, we are assuming 2-3 things. One equation is AX plus BY plus CZ is equal to, let's say, D1 taking. Okay, where the normal vector is AI plus BJ plus CK, okay, and that PQ is what, because P and Q are taken 2 points, if I join those 2 points will give you a vector that PQ will be x minus x0I, y minus y0j and z minus z0k. This will be the equation. These are the unit vector. Okay, fine. So now if I do the vector n dot product to PQ, it's nothing but the vector n mod vector PQ mod and the cos theta, the angle between this, if I do the dot product. So now what is this one? This is nothing but D. So I can write the mod of this into D, where D is the on the magnitude. So what is D that we are talking about? You can say this is commutative, so we can change the position. So this is n divided by the mod n. What is this? This is nothing but the unit vector along the normal vector. Okay, so now if I calculate the normal vector, which is nothing but vector upon the mod value, what is that? This n vector is taken as this one, the a1I plus bj plus ck under root of mod of n is equal to nothing but the square root of the sum of the squares of the coefficient, this one. Now all this I can rub it. Okay, so now if I put it right now on the equation, the D will become what? PQ vector dot n unit vectors along this. So unit vector will find. So PQ is what? PQ is x minus x0 I, y minus y0 j plus z minus z0 k dot, that this one is equal to AI plus BJ plus CK under root of a square plus b square plus c square. Okay, now if I do the dot product between this will remain as a x minus x0 plus b y minus y0 plus c z minus z0 upon a square plus b square plus c square. Now we understand D is a magnitude only, so we can put it into mod. We will not consider that any sign if it is coming negative also. So now this is what? Ax plus by plus cz in one bracket minus ax0 plus by0 plus cz0 divided by under root of a square plus b square plus c square. Now ultimately what is your D finally? This is, I have taken the plane equation, P1 equation as ax plus by plus cz is equal to D1. So this is nothing but what? D1. So now if I take minus sign from there, so it will become minus. So ultimately ax0 plus by0 plus cz0 minus this will be replaced by D. So now it is D1 because the equation is such. So this is become a square plus b square plus c square. So yes, you can see all are constant. A is a coefficient, x is a point, which is fixed point that from where we have to calculate. So this is D1 also constant for a plane equation. So all are constant. So D is can be calculated by this formula. Understood? So now we will do some sum. and we'll close this chapter. Now moving to the problem. The first problem that we will do on the coplanarity, because there I have only discussed the conditions and the theories. I have not proved anything. I have not solved any problem. So we'll do some problem, but that are very similar to the theory itself. The only thing is the clarity. You have to solve one or two problems. So determine whether this 3 point is given x 1, 2, 3, y is 1, 1, and z 1, 2, 1 are coplanar. This has to be proved a coplanar. So what was the condition of a coplanarity if it is x, y, z? So triple scalar product has to be 0. Now this is nothing but what? The component of 3, this is y1, y2, y3, and this is z1, z2, z3. That matrix has to be 0. Now what are these? X, if it is, can be represented by x1i plus x2j plus x3k. So now point you can take this point. So this is nothing but I, because it is 1, plus x2 means 2j, and plus x3 means 3k. Similarly, y is I plus j plus k, and z is I plus 2j plus k. So now put this value here, or if I put the value here, it is 1, 2, 3, 1, 1, 1 and 1, 2, 1. Now I have to solve it. It has to be 0. So now this is 1 in the bracket, this into this 1, 2 into this, minus 2 into this, 1 into 1, 1, minus 2 into 1, that means minus 1. That the second one will be minus 2 into this 1, 1 into those, this will be 1 minus 1, that will be 0, 2 into, and the second one is, third one, 3 into this 2, 1, so this will be 3 into 1. Okay, so ultimately this is minus 1, minus 0, plus 3. 1, 2, 3, 1, 2, 3, 1, 1, 1, 1, 2, 1. So 1 into this, minus 1. Then 2 is equal to 1 to this into this is 0. And 3 into this, minus 1. So this is ultimately coming 2. So this is not equal to 0. So these lines are not coplanar. This is non-coplanar. Okay. I'm correct. If it is x is 1, 2, 3, 1, 1, 1, 1, 2, 1. So 1 into this 1, 2 into this 0, 3 into this yes. So these points are non-coplanar. Okay, now moving to the next problem. The problem number 2. These are similar kind. These are very easy problems. So, but still, one or two problem has to be shown to understand. This other way it is being represented directly. So these are the 3 vector minus 5k, and the third one is 3i minus 4j minus 4k. These are the three vectors given. So we can assume it is x, this is y, this is z. So our triple point product, triple scalar product will be this. This has to be 0. So now we can take the matrix. This is the x component 2 minus 1 1, y component is 1 minus 3 minus 5, z component is 3 minus 4 minus 4. So if we calculate it, I will get 2 into 3 minus 4, this is minus the plus 12, this into this is 4, this is minus 4 and this is minus, yes. So the first one is 2 into minus 3 minus 12 minus of 20 minus 1, so this will be plus 1 into 4 minus 4, this into this minus plus 15, and the third one is 1 into this minus 4 and this into this last one is this into this minus 4, this into this, so this will be plus 9. So ultimately the value will be minus 8 to minus 16, this will be 11 plus 11, and the last one is plus 5. So now you see the value becomes 0. So these these vectors are coplanar. So we have proved if the triple scalar product is 0, then these are coplanar. So this is the end of the coplanarity. Now I will solve one problem on the calculation of distance from a point to the plane. So this is the problem 3. Find the distance of plane whose equation is 3x minus 4y plus 12j is equal to 3. Okay, so from the origin, from the origin. Okay, so now you can see that what we have did solution. So what you did, the p point is x0, y0, z0 if it is the point vector. So now this case is origin. So for our case it is equivalent to 0, 0, 0 our xy0, and the distance we have found, it is nothing but the same equation, ax0 plus by0 cz0 minus d divided by this one. This was my formula to calculate distance. Now here a, b, c are these points, so you can put directly value of x, y, z is equal to 0 here. So all will be 0, 0 plus 0 plus 0 minus this one. So this is already on the right hand side, this come as a minus, so this will be 3. It is in the form of equation. This is, if it is after coming to this side, it is minus automatically. So we'll put the value. So just remember that you need not to multiply another minus, because this is in actual form. It is, if it is kept on the left hand side, it will be this one. That means ax plus by plus cz minus d is equal to 0. So there is no need of changing the sign. So this will automatically come 0 minus 3. So then a square, b square, c square means 3 square plus 4 square 5 square plus 12 square. That means it is 3 square plus 4 square plus 12 square. So ultimately 25 plus 144, that means 169, that is equal to 13. So this will become, as because we will not consider any negative sign, only the distance will cover. So So this will be 13 by 3 by 13. So this will be the distance between the thing. Okay. That's all from now. So this is the end of the vector. Now we'll move into some other subjects, maybe on the mathematics. Then after I will come back to the physics subjects again. So by now it is ending the session on vectors, and thank you for watching. Keep subscribing channel, keep watching for such to discuss more on subjects that will be useful for your academic life. Thank you.